Dear friends, today we are going to see about two problems. The first one, problem number 9, assuming that f and g have antiderivatives. You have to prove integral a to b f of x plus g of x into dx equals integral a to b f of x dx plus integral a to b g of x dx. What is the solution? So, first what you are going to do is f be an antiderivative of small f and g be an antiderivative of small g. So, by definition we know that capital F dash of x equal to small f of x and capital G dash of x is equal to small g of x. So, using the sum rule for differentiation we get d by dx of capital F of x plus capital G of x, it is equal to d by dx of f of x plus d by dx of g of x. So, you will get derivative, that is f dash of x plus g dash of x. What is capital F dash of x? It is nothing but small f of x. Capital G dash of x, nothing but small g of x. So, you are getting the final answer like this. So, you can say that f plus g, capital F plus g is the antiderivative of small f plus g. So, you are finding the values integral a to b f of x plus g of x into dx. It is equal to capital F of x plus g of x within the limits a to b. Capital F of b plus g of b minus of capital F of a plus g of a. That is capital F of b minus f of a plus capital G of b minus g of a. Capital F of x within the limits a to b plus capital G of x within the limits a to b. So, integral a to b f of x dx plus integral a to b g of x dx. So, the 9th problem is over and next come the 10th problem. It is a very simple one, assuming that f and g have antiderivatives. We have to prove that if f of x is less than or equal to g of x for all x which is satisfying the condition a less than or equal to x less than or equal to b. What will happen then? Integral a to b f of x gx dx less than or equal to integral a to b g of x dx. How will we prove that? For the solution, let again capital F be antiderivative of small f, capital G be antiderivative of small g, then by definition you will get capital F dash is small f, capital G dash is small g. So, if small f is less than or equal to small g on interval a b, then capital F minus g the whole dash of x is equal to capital F dash of x minus capital G dash of x is equal to small f x minus dx. It is always less than or equal to 0 for all x in interval a b. Since a function as negative, a function with a negative is decreasing, we will get in the next slide we can see that f of b minus g of b minus of f of a minus g of a is always less than or equal to 0. F of b minus f of a minus of g of b minus g of a is always less than or equal to 0, means f of b minus f of a less than or equal to g of b minus g of a. F of x within the limits a to b less than or equal to g of x within the limits a to b. So, by fundamental theorem of calculus you can see that integral a to b f of x dx is equal to small f of x within the limit a to b, that is less than or equal to g of x a to b, it is equal to integral a to b g of x dx. Now, next we are going to see about fundamental theorem of calculus, the alternative version. If f is continuous on closed interval a b, then d by dx of integral a to x f of s dx is equal to small f of x. We now justify the alternate version of fundamental theorem. To prove the above theorem, what we have to do is first we prove if small f is continuous on closed interval a b, then small f is an antiderivative capital F in closed interval a b. But to prove this we need a theorem which is known as mean value theorem for integrals. So, we will see about that, which is not at our disposal now, but we will prove the above theorem by assuming certain things. So, we are going to assume that small f has an antiderivative capital F on closed interval a b. Then, if capital F is antiderivative of small f on closed interval a b for any x which is element of a b, the fundamental theorem of calculus we get integral a to x f of s within the limits a to x is equal to capital F of x minus capital F of a. So, when you are differentiating on both sides, d by dx of integral a to x f of s ds is equal to d by dx of capital F of x minus capital F of a, d by dx of capital F of x, because capital F of a will be a constant. So, the final answer is small f of x, because capital F is the small f is the antiderivative of capital F. Now, the alternative version of fundamental theorem is proved. For the remark, the alternative version of the fundamental theorems of calculus is an illustrating and illuminating interpretation and explanation in terms of the areas. What is that? Suppose f of x is non-negative on closed interval a b. Imagine uncovering the graph of small f by moving a screen to the right, as which is given in the figure 5.8 in your textbooks. When the screen is at x, the exposed area capital A, it is equal to a to x small f of s ds. Now, what will happen? So, what will happen is that this is the given figure. Here in the interval a to b, in between you are getting an x, then there is a screen which is placed like this, and there is an area a which you are marked like that, and the x axis and y axis is specially marked. In the next slide we can see that the alternative version of the fundamental theorem can be replaced as follows. What will happen as the screen moves to the right? The rate of change of exposed area capital A with respect to x, that is capital A with respect to x means d capital A by dx, it equals small f of x. The same conclusion can be seen graphically by investigating the difference coefficient, that is capital A of x plus delta x, the final value, minus capital A of x, the change in areas, whole divided by delta x. So, in the next slide you can see in the figure, you can see that a to x is given, then f of x values you can see, then in between a and x you have marked a small slide, small short x and a small length, then f of x values are given. So, you can see that the quantity a of x plus delta x, the area minus a of x is the area under the graph of f between x and x plus delta x. So, for this small delta x, this area is approximately the area of the rectangle with the base is delta x and the height is f of x, which is given in the figure 5.9. That is x is a point and x plus delta x is the next point. So, you are going to get here a of x plus delta x minus a of x by x, it is equal to f of x into delta x whole divided by delta x minus f of x. So, the limit delta x tend to 0, a of x plus delta x minus a of x whole divided by x, delta x is equal to small f of x, and this will imply d capital A by dx, it is equal to small f of x. Thus, if f is continuous, this argument is the basis for rigorous proof of the alternative version of fundamental theorem. So, I hope you know to do the problems. So, we will stop here. Thank you, dear friends. We will meet in the next class.